The universe is a symphony of change. It's a grand orchestra where every element, from the tiniest particle to the largest galaxy, plays its part in a never-ending performance. From the grand dance of galaxies to the intricate workings of a single cell, everything is in a constant state of flux. This perpetual motion is what makes the universe so mesmerizing and complex. Everything is in a constant state of flux, just like a cricket match, where every ball, every run, and every wicket can change the course of the game. The universe, too, is always evolving. Understanding this change is key to unlocking the secrets of the cosmos. By studying the patterns and rhythms of change, we can begin to understand the underlying principles that govern everything around us. Imagine a rocket launching into space. Its velocity isn't constant, it changes every second as it burns fuel and escapes Earth's gravity. This is a perfect example of how change is an integral part of progress and exploration. It changes every second as it burns fuel and escapes Earth's gravity. Similarly, in a cricket match, the strategy and momentum shift with every ball bowled and every shot played. Now consider the graceful arc of a roller coaster. Its speed fluctuates as it climbs steep hills and plunges into daring drops. This ebb and flow is what makes the ride thrilling and unpredictable. Its speed fluctuates as it climbs steep hills and plunges into daring drops. In the same way, a cricket match is filled with highs and lows, moments of tension and exhilaration. These examples illustrate the dynamic nature of our universe. They show us that change is not merely a constant, but a fascinating puzzle to solve. Each change, each shift, brings with it new opportunities and challenges. They show us that change is not merely a constant, but a fascinating puzzle to solve. Embracing this symphony of change allows us to appreciate the beauty and complexity of the world we live in, and to find our place within it. In our quest to comprehend change, we turn to a powerful tool in mathematics: integration. Integration allows us to calculate the accumulated effect of these changes over time. Imagine trying to measure the distance a rocket travels as it constantly accelerates. You can't simply multiply its initial speed by time. That would only work if the speed were constant. Integration provides the solution. It allows us to sum up the infinitesimal changes in velocity over infinitesimal intervals of time. This gives us the total distance traveled. The applications of integration extend far beyond calculating rocket trajectories. Let's return to our roller coaster example. Integration can determine the exact length of the track needed for those thrilling twists and turns. It can calculate the total energy the coaster possesses at any point on its journey. Engineers use integration to design bridges that can withstand varying weight distributions. Economists use it to model the growth of markets and predict future trends. Integration is a fundamental tool for understanding and predicting the behavior of systems that change over time. Integration is intricately linked to another fundamental concept in calculus. Differentiation and integration are two sides of the same coin. Differentiation tells us the rate at which something changes. It gives us the instantaneous rate of change. Think of it as the speedometer in your car, telling you your speed at any given moment. Integration, on the other hand, tells us the total change over a period of time. It's like looking at the odometer to see how far you've traveled. Section 5, Antiderivatives, Unlocking the Secrets of Change. To fully grasp integration, we need to understand antiderivatives. An antiderivative is the reverse of a derivative. If we know the derivative of a function, its antiderivative helps us find the original function. This is crucial in integration because it allows us to work backward from the rate of change to the original function. Finding antiderivatives is a key part of solving integration problems. It allows us to unlock the mysteries hidden within the language of change. Section 6. Integration at work areas, volumes, and beyond. Integration is a powerful mathematical tool that finds applications in numerous real-world scenarios. The power of integration extends far beyond finding distances and velocities. It is a fundamental concept that helps us understand and solve complex problems in various fields. It allows us to calculate areas, volumes, and other quantities that are crucial in various fields. For instance, in engineering, integration is used to determine the stress and strain on materials. Imagine trying to calculate the area of an irregular shape. This could be a challenging task if we were to rely solely on basic geometry. Integration provides an elegant solution. By breaking down the shape into infinitesimally thin slices, we can sum up their areas to get an accurate measurement. It allows us to break down the shape into infinitesimally thin slices and sum up their areas. This method is not only precise, but also versatile, applicable to a wide range of shapes and sizes. This principle extends to calculating volumes. Just as we can find the area of a two-dimensional shape, we can also determine the volume of a three-dimensional object. We can think of a three-dimensional object as being composed of infinitely thin slices, each with a specific area. By summing up these areas, we can find the total volume. Integration allows us to sum up the volumes of these slices to find the total volume of the object. This technique is invaluable in fields such as physics, engineering, and even economics, where understanding the total quantity is essential. Whether it's calculating the area under a curve, the volume of a solid, or any other complex quantity, integration provides a robust framework for solving these problems. Its applications are vast and varied, making it an indispensable tool in both academic and professional settings. So the next time you see a cricket field or any other complex shape, remember that integration is at work, helping us understand and quantify the world around us in ways that are both profound and practical. Section 7. Mastering the techniques, substitution and integration by parts. In this section, we will delve into the intricacies of these two powerful methods that are essential for solving complex integrals. While the concept of integration is relatively straightforward, actually performing integration can be quite challenging. Just like a cricketer needs to focus and strategize before making a move, mathematicians need to carefully choose the right technique to solve an integral. Over the centuries, mathematicians have developed various techniques to tackle integration problems. These techniques are akin to the strategies developed by cricket teams over the years to outplay their opponents. Two of the most common techniques are substitution and integration by parts. These methods are like the fundamental strategies in cricket that every player must master to excel in the game. Substitution, also known as U-substitution, involves substituting a simpler expression for a more complex one within the integral. This technique simplifies the problem, much like a cricketer adjusting their grip to make a perfect shot. This often makes the integral easier to solve. When done correctly, it can lead to a straightforward solution, just as a well-executed shot can lead to a boundary. Integration by parts is a more advanced technique used to integrate products of functions. This method is like the all-rounder in cricket, versatile and capable of handling complex situations. It involves breaking down the integral into two parts and applying a specific formula. This technique requires a deep understanding of the functions involved, similar to how a cricket team needs to understand the strengths and weaknesses of their opponents to strategize effectively. Section 8. Conquering challenges, strategies for integration success. Integration can be a daunting task, even for experienced mathematicians. The key to conquering integration challenges lies in practice, patience, and a willingness to explore different approaches. One common challenge is identifying the appropriate integration technique to use. Sometimes a problem may require a combination of techniques. Another challenge is dealing with integrals that cannot be solved analytically. In such cases, numerical methods can be used to approximate the solution. Section 9. Visualizing integration, making complex concepts clear. Visualizing integration can be incredibly helpful, especially when dealing with complex problems. Graphs, diagrams, and real-life examples can make abstract concepts more concrete. For instance, imagine trying to calculate the work done in compressing a spring. Visualizing the spring and the force required to compress it can make the problem more intuitive. Similarly, graphs can help us visualize the area under a curve, making the concept of integration more tangible. Section 10. The power of integration, unveiling the secrets of the universe. Integration is more than just a mathematical tool. It's a key that unlocks a deeper understanding of the universe and its intricate workings. From the motion of celestial objects to the behavior of subatomic particles, integration helps us decipher the language of change that governs the cosmos. By embracing integration, we embark on a journey of discovery, unraveling the mysteries of the universe one integral at a time. Section 11. Embracing the challenge. A journey of continuous learning. Mastering integration is a journey, not a destination. It requires dedication, practice, and a willingness to embrace challenges. Don't be afraid to make mistakes. They are valuable learning opportunities. Seek help when needed. There are countless resources available, from textbooks to online tutorials. Remember, the most important thing is to approach integration with curiosity and a thirst for knowledge. The universe is full of wonders waiting to be discovered. Integration is your passport to explore them.